how would you name the one on the right? Okay, so this one, you want the branches to be, have the lowest number, right? So you need to start at these 2 carbons for sure. So, same idea as before. If they have the same importance, right? You can go 1, 2 going counterclockwise, or 1, 2. Oh wait, that's clockwise. Or 1, 2 going counterclockwise. So you tell me, which one should you start? Which branch should you start? They're both 1 and 2 either way. So what do you think? Doesn't matter. Of course it matters. Right, ethyl, right? Because E comes before M. Right, so you would go this way. So it would be 1 ethyl, 2 methyl. Whoops, there's a dash there. But yeah, cyclopentane. Right, it's the same idea as before. All right. So lowest numbers first. If they're the same, then you go for the. Yeah. Can you do? Yeah. Sure. We can do a similar example. Do you mean Okay. So yeah. So yeah, if the branch contains a double bond, then the branch would take that would take priority. Okay. So let's do a double bond example first. Okay. So let's do the same thing. So it's a cyclopentane. Let's make a cyclopentene, and then let's add something like this. So for this one, right? How would you name this? Well, the double bond takes priority, so you want the double bond to have the lowest number. Okay, so you got to go. Let's see, 1, 2, 3, 4, 1, 2, 3. So you go 1, 2, 3. 4, 5. Okay, so that's what it is. Question 5, sure, I'll do question 5. Why would it be the other way? Why would it be the other way? If you go the other way, it would be 1, 2. Wait, hold on. It's not 2 point. There we go. It would be 1, 2, 3, 4, 5. Your branches would be 4 and 5. If I count using the black one, it would be 3 and 4. Right? So a mistake that some people make is they don't follow the rule of counting through the double bond. So sometimes I will see like something like this. They start counting like this, which is wrong. So I go 1, 2, 3, 4, 5. And you can't do that. Okay, you have to count through the bond. Okay. Yeah, so if branches, okay, so we'll get to it. We'll get to that question. Save it. Because that's the end of the lesson. That's the end of organic 1. That's the end. Okay, so save the double bond branch question. That's the end of organic 01. So we'll get to it. Okay, I'll get to it. Don't worry. Okay, Victoria, I have a question about cis and trans compounds on the Bob. Okay, there's no possible way you can do the You can't do the Bob worksheet. There's no way for you to do the Bob worksheet yet. There's no way for you to do the Bob worksheet. How do you do Bob? We haven't even finished organic 2 yet. There's no way for you to do it. You fit. Okay, well, you're really ahead, and you know how to do multiple functional groups then. So you're about like 2 lessons ahead. So I wouldn't worry. You can't do Bob yet. But I guess yay for effort. Yeah. No, it's in that order because it's by alphabetical order. It's not. I can't. Yeah. Okay. Yeah, it's fine. You're ahead. Whatever. You're, no. Stop worrying about Bob. We're not at Bob yet. Don't ask about Bob. Okay. So before. Okay. So Heather's question. Okay. So we'll talk about cis and trans. Heather's question was in the alkanes worksheet. Question 2. The molecular formula for non-cyclic alkenes is C4H10, which is perfect. But is C4H8? C4H8, really? I don't remember. C4H10 alkanes work. Okay, stop typing. It's scrolling. Which one? Crap. Alkanes, question 2. Okay. Based on the safer, but technically, how come there are only 8 hydrogens in cycloalkanes? Non-cyclics will follow this one, CnH2n plus 2. That's for alkanes. For cycloalkane, right, if you think about it, it's CnH2n because you close the structure. So a butane looks like that. The full structure or the condensed structure is CH3, CH2, CH2, CH3. If it's a cycloalkane, right, you get CH2, 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 CH2. Oops. So it's CnH2n for cyclos. Yeah. Huh? Yeah, okay, cool. Okay, so that's done. Yo, stop asking about Bob. Jesus Christ. Listen, I know what I'm doing. Just wait. You'll get to Bob later, and you're gonna hate it. I'm pretty sure Victoria hates it. Okay, so just wait. All right. Okay, where are we? All right, cis and trans. So the thing we ended off yesterday was cis and trans. All right. So any issues? Hopefully you all watched the video, so you all saw how the 3D structure actually looks like. All right. So cis and trans. You didn't actually answer my question though. Yeah, because we're not there. You're the only one that's there. Okay. Cis and trans are all examples. Can they have both? Yes, I'm getting to that. I'm getting to that. Yes, there can be both. Okay, so for example, something like this. If I put a double bond here, and then let's see. Well, I gotta erase it actually. And then I put a double bond here. All right. So here, there are 2 places for cis and trans. This conformation is going to be trans, and this conformation is going to be cis. Okay. So there can be multiple places where it can be cis or trans. Right? But right, to make life a little easier, I will only give you examples with just one. Hence, Victoria, on the worksheet, there's only one cis or trans, if it appears. You would need to say where it is. So you would need to include a number. So this would be 2, right? Well, if I count this way, yeah, it doesn't matter which way I count. Yeah. And this one would be 1, 2, 3, 4, 5, 6. This one would be 6.
Oh,
So
hi.
yeah, you
I
would
made a
need
couple
to
of models,
designate,
and both of these models, the one
where the
sitting on the
cis and
counter,
trans is, right? But again, for simplicity's sake, right, just gonna do one, if any, one per molecule. Okay, so there is that. But yeah, we ended off with cis and trans, so you should be able to tell when cis and trans happen. Again, cis and trans happens when there's rigidity. So you can tell something is cis or trans when you look at, right, when you cut open the double bond and you look at how many things or the different attachments. So you focus on these 2 carbons, right? And the issue, I guess, with line structure is that it doesn't show the hydrogens. All right. So here is trans because if I focus on what I call the smaller chain, so I take my left hand and I cover up the left side. The smaller attachment, right, this is H, which is the smaller one, it's pointing up. If I take my hand and I cover up the right side, the smaller attachment here of this carbon, the hydrogen is pointing down. So it's a cross, hence trans. I can do the same thing on the other side, right? The other side I told you already is cis. So you want to cut it open and you want to look at the different attachments on these 2 carbons. So in this case, the smaller one, both of them are pointing in the same direction, hence cis. Right? That's how cis, and that's how you can you do cis or trans. If there's only one, do we need to state it? No. No. So that's why I'm sort of keeping it simpler. You can do both, right? You can do both, right? It doesn't matter. Like if I look at the bigger one, does it really matter if I do the bigger one? It's the same idea, right? Here I just took the smaller one. If you want to do the big one, go for it. So for here, it's still trans. The bigger one is pointing down. The bigger one is still pointing up. It's still opposite, so it's still a cross, right? Like it's up to your preference. If you want to do bigger, go for it, right? Just make sure you're looking at the bigger on both carbons, right? Here I'm looking at the smaller for both carbons, so I'm keeping it consistent. So yeah, that's how you do cis or trans. All right. So yeah, so let's do a quick test. Let's try this. For this really simple compound, relatively simple compound, is there a cis or trans conformation for this that I just drew, for this molecule that I just drew? X1-ene. No. Okay, good. Because it's on the ends, right? If I draw in the hydrogens, no, there's no bigger or smaller side, right? If I cut it open, right, these 2 are the same things, right? So it can never appear on the ends. Okay, so that's what it can never appear if the chain, if the branches, if the attachments are the same. Okay, so that's essentially what it is. All right, and another one, most of you know this, you can't have smaller or bigger if it's a triple bond as well. Right? Because this is completely filled. This is completely, these 2 carbons are completely fully, packed in. So, if you draw an extra hydrogen here, that will be incorrect, right? So there are no cis or trans when triple bond happens as well. Okay, so I answered that question. There you go. All right, so cis or trans, done. Whew. All right. So we did cyclose. Okay. I did cis or trans. No, Terry. No. Right. So again, cis or trans can't happen with a triple bond, right? Because if I draw this, right? If I draw this, this is what it looks like. right? And this is, CH3, and this right here is a CH2. Obviously, there's more stuff here, but when you cut this in half, when you cut a triple bond in half, can you have a bigger or smaller side? Well, no, there's only one thing that's attached to it, right? So you can't have a sister trans with a triple bond. It's just not possible. Okay. Okay. So anything else? A ring with double bond, sure. What about it? I will get to a double bond on a branch at the end. If you look at organic 1, the last question has a double bond on the branch. So just wait. I know you're anxious, but just wait. It's coming. It's coming. Okay, so I'm gonna move on. Okay, so question 5 of organic 1. This one's a little tougher. So this one deals with like this. I think. Oops. Right? Yeah, something like this. Yeah. Wow, that's horrible. Okay, so yeah, so in terms of naming, right, you want to give the double bonds in your cyclos the lowest number, right? So in this case, you would go 1, 2, 3, 4, 5. All right, so the 2 is pretty easy. This is 2-methyl, right? The parent's pretty. Hopefully you can all do it, which is a cyclo hex 1,3-die, right? So the problem here is with the branch, right? So the branch here, it goes 1, 2, 3, 4. So this is going to be 5 bute, 3 ene, and you can have an extra e in there, whatever, it doesn't matter. It's like English, right? 2O, right? So that's what number 5 is. So let's break it down, because it gets confusing. So at carbon number 5, right, of the parent chain, there's this branch. It has 4 carbons, right? So you can see clearly there are 4 carbons. At carbon number 3, there is a triple bond, or sorry, not triple bond, double bond. The 2 means that carbon number 2 of the chain is attached to my parent. All right, so that's why there's 2O. And we have to start counting this way, because we want this carbon right here to have the lowest number, because our parent is the more important thing. So we want to give this carbon the lowest number possible. Hence, it goes 1, 2, 3, 4. You don't count from right to left, right? Because then you would get a number of 3 for the carbon that is attached to the parent. So that's why you have to count it this way. All right, good. So that's number 5. Uh, 2O, because this is the carbon. It's carbon attached to parent. There we go. Carbon attached to parent. Is the top part a complex? It's a It's considered complex, yes, because we got numbers inside our branch. Well, for the naming, we got numbers within the naming of the branch, hence we use the brackets to sort of organize and separate it. Okay, so the full name altogether, so B before M, so it's, well, no, I don't need to give it. It's in the thing. The full name's already given in the handout. So are the parentheses represent a sub-branch? And not a sub-branch. I wouldn't say a sub-branch. It's not like it's a branch on a branch. It's just that whenever we have numbers involved with the branch, we have to indicate something that is on the branch. It doesn't have to be a branch on a branch, but anything unique, I would say, that's that has to be indicated on the branch. We start using the brackets. What if, let's say, the ring is only made of single bonds? Okay, so again, Terry, you're asking about double bonds on a branch. So just wait, it's coming. I promise you it's coming. So yeah, if there are no questions, I can move on to Terry's dying question. Complex branches aren't the norm. So on a quiz or something like that, maybe for the whole unit you might see one, but that's not something we stress too much on. That's not something that I stress on. I mean, it's good to know, but it's it gets real complex, as you can see. Like, you can tell, like, we're just doing single bonds and double bonds, or triple bonds right now. We haven't even gotten to the multiple group. Okay. How do I explain it? I don't know. So this carbon, I don't know. This carbon right here, this is carbon 2. Normally speaking, right? Normally speaking, we don't include, for something like this. Let's make it more, right? For something like this, so 1, 2, 3, 4. This is my branch. 1, 2, 3, 4, 5, 6, 7. Oh wow, that's not even a branch. Stupid. No, that's not a good example. Yeah, let's do this. 1, 2, 3. There. 1, 2, 3. 1, 2. Oh, son of a. 1, 2, 3. There we go. So yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So normally speaking, no name, right? Pretty simple. And you just go, okay, 5, 2, 3, 4, 5. Okay, yeah, 5. Good. 5 propyl. We don't usually write, because it's implied. So technically speaking, you can go like this: prop 1-ol, no name. Right? It just says, hey, the branch, it's attached, carbon number 1, it's where it is attached to the parent. Same idea here. This is just saying carbon number 2 is the site of attachment. It's where it is linked. It's where the branch is linked to my parent. Okay? It's where it is linked. Yeah. So, yeah. So you don't usually see this because it's implied. But here we have to specify, because it is now on carbon number 2. It's no longer a carbon number 1. Okay? Okay, so cool. Okay, so aromatics. Okay, so let me first explain what aromatics are. Okay? Aromatics look something like this. So this compound right here is called a benzene. All right? Aromatics is kind of cool because the characteristics of an aromatic compound, number 1, properties-wise, they smell nice. Okay? That's what you sort of smell in certain chemicals, that sort of nice floral scent. Structurally, in terms of the structure for aromatics, it always skips a spot. So you got a double bond, it skips a space, and then another double bond skips a space, and then another one. Okay, and that's because aromatics are quite cool in the sense that they can rotate. The double bonds can rotate around. So this can go here, this can go here, or opposite direction. It really doesn't matter. So this is what we call delocalized electrons. Delocalized electrons. All right. So they can always flip around. So another example of an aromatic compound is like this. It's a cyclo compound, and it looks like this. The double bonds can shift around in your ring structure. So you get something like this. Okay. And it's cool because, the data that we find in regards to the bond length, it's quite amusing because single bonds, carbon-carbon single bonds, are much longer than carbon-carbon double bonds. So, if we draw this, it looks kind of weird, right? Because you got something really short, and then you got something long, and then you got something short, and you got something long, short. So it looks something like this, which is super weird. That's not the case. We found that, for benzene, the bond length is exactly the same. And when we measure it, all the bond lengths, somewhere in the middle. It's like bond 1.5. It's not like a single bond, but it's not quite like a double bond either. The bond length is somewhere in between the two, somewhere like right here, in between the two. So why exactly is that? That's because the electrons are capable of rotating around, spreading themselves out. So really, and your textbook will show, your textbook sometimes, some textbooks actually do this, right? They will show this to be the correct structure of benzene, to show that the electrons are constantly moving around, back and forth, delocalized electrons. All right, and the IUPAC name, the official name is cyclo hex 135 triene, right? But nobody uses his name. We always just use benzene because this thing has been around for a long time, and it simply saves us the hassle of saying cyclo hex 135 triene. That's what aromatic compounds are. All right. So in terms of naming, just like your cyclo compounds, you want to give the branches the lowest number as well. You don't really need to worry about the double bonds because, as mentioned, they rotate around. So question number 6, right? Question number 6 looks something like this. Right? So you want to give them the lowest number possible. Can we draw? Yeah, you can draw either double bonds or the circle. Doesn't matter. Both representations are correct. So yeah, you would want to give the branches the lowest number possible because you don't need to worry about, right, the double bonds because they it's an aromatic, they can move around. All right, so it will be 1, 2, 3, and 4. Okay. So I believe I did this one. How do we know the location of the double bond? You don't know the location of the double bond because it moves around, right? That's why we draw the circle. Because it's a delocalized, right? It's moving around. There's no exact way, unless you can freeze time, right? You can't just say, oh, the double bond has to be here. Okay? Why can't ethyl be 1? Because they have the same importance, right? You want the lowest number first, and then you can, if the numbers are all the same, and then you take into consideration alphabetical order. How do I decide where to count? Well, again, this will give me the lowest number possible. If I count the other way, 1, 2, 3, 4, 5, right? That's not good. Right? This is the only way to give it the lowest number. Okay? And they have all the same importance because they're all single bonds, right? So yeah, this would be 1,2-dimethyl, 4-ethyl. All right? So this one should be okay. So the next one, this one's slightly more difficult. So 6B or something like that. Like, yeah, it's on the right side. So this one looks like this. And let's separate this. There we go. So yeah, this one. All right. So this one you can't really use. Right, Cindy, see, I got to it. What happens when a branch has a multi-bond? Right, Terry? See, I'm not lying when I said I'll get to it. Okay. So here, you need to give this guy the lowest priority or the lowest number. All right. So you have to start counting this carbon. Right. So the only way is if you go clockwise. So 1, 2, 3, 4, 5, 6. All right. So this is an ethyl, pretty simple. This is a methyl, pretty straightforward. This branch, right? So this is going to be 1, 2, and 3. So this is a prop 2 inal. Okay, so the whole thing together will be, let's see, 3-methyl, 3-ethyl, 4-methyl, 1 prop. Got to put a bracket there because there's a number there. I know. Benzene. Okay, does that make sense? And yeah, that's how you do that one. So the bracket is after methyl because what? Well, propyl it's after methyl because P after M. The bracket it's because we have it's getting more complex. We now have a number within the branch. We have to indicate stuff on the branch. So that's why there's a bracket. Okay. Any other questions? Any other questions, people? What if ring is single bond only? Well, it doesn't, Terry, it doesn't change anything, right? You still name it the same way. Except that it's now a cyclohexane. That's it. Okay, well, we can try it. What difference does it make? Okay, so yeah, what difference does it make? Oh, so you're saying, okay, I see what you're saying. So you're saying this is a branch. Oh, sorry, no, that's the parent, and this is the branch. In that case, you have a cyclo branch. So that would be more complex. Yeah. You probably won't see that, so I wouldn't worry. I don't have time to teach you all the naming for single bonds. Okay. Okay, so let's see. Is it supposed to be a bend before the double bond on the branch? Okay, so right now you might want to draw it like this. So 1, 2, and 3. That's fine. The reason why why my computer program decided to do this is because it's following something called Vesper. So Vesper looks at the 3D orientation of the atoms. When you have a triple bond, the structure is linear. Hence, the computer did this. Right? When I'm doing my triple bond, I'm not really thinking about Vesper at all, right? I'm just doing like random carbons and adding stuff on there. So that's why you see a kink. But yeah, the computer, so this, some of you might have seen this on the worksheets or something like that, but yeah, the computer takes into consideration what we call Vesper structure, which is the 3D. So they try to draw it as structurally correct as they can. So they kind of they took out the kink. So it goes straight. You can do both. I'll take both because you haven't learned Vesper yet. Well, some of you haven't, some of you did. I don't know who. But yeah, I'll take both for now. Right. So phenyl and benzyl. Okay. Right. Okay. So phenyl. Yeah, got space here. Phenyl is when benzene is a branch. When this is considered to be a branch, this is phenyl. That's the name for it. I don't know why. I don't make up these rules. This branch is called a benzyl. You would think that, the one with the benzene ring would be called benzyl, but no. Benzyl is, there's one carbon right here, and then there is the benzene ring. So when you have something like super complex and you have these guys as a branch, right, then it's called a phenyl, and that's called benzyl. When is a branch form is called phenyl, yes. Okay. Terry asked earlier when to consider rank. It's the same idea as before. The longer length. Okay, look at length. The longer one is considered to be the parent. Okay, not obviously again not including double bonds or triple bonds. If we just purely look at length, and the longer one is the parent. So whichever one's longer is the parent. That's it. When we have double bonds and triple bonds, then we have to consider those first. Those would be the parent, and then yeah. Are multi-bonds more important than cyclics? Yes, they are. So I don't know. This is tough to name because then you got like two branches on a branch. Which, don't worry. I'm not going to give you such a complex branch, but something like this you can probably do. Let's see. Let's give it a double bond here, and then don't know, something like this. Oops. This is something that you can do. So this should be named. Yeah, you can probably name this with no problem. So before we move on to 2, what's the name for this? So if you're finished with that one, you can try this one as well. Guys, let's see. Have 2-ene, good. Cyclopropyl, excellent. 4-cyclopropyl, good. 4,5-dimethyl, good. So close though. So missing one thing. You would get a 1.5 here. It is missing one thing. Yep, there you go. Trans. So yeah. So that's what it is. Yeah, so yeah. But yeah, go on to the benzene structure. Dimethyl. Four. Oh, actually, no. I have to fix something. Have 2. Sorry, I actually have to fix something. Yeah. The cyclo actually goes first. Apologies. Yeah. Yeah, C. It is, but it involves structures. So within the IUPAC naming rules, anytime it's structure related, we count that. When it's number related, we don't count it. So di, tri, tetra, we don't count those. When it's structure related, so cyclo, it has something to do with the structure, we count those. But yeah. It sounds like I'm making this up, but I assure you I'm not. If I am the person making these things up, I will not be here teaching you. Okay, so okay, so the benzene. Any idea on the benzene? Oh, sorry, Stephen. I didn't even see yours. Okay, 1-cyclopropyl, 3-ethyl 4,4-dimethyl. I would switch the naming around, Stephen. I would switch the naming around. They're all just branches, right? So you would start here. So it gives a 1, 1, 2, 4 for branches. Yeah. So cyclopropyl, 2-ethyl, 1, 1. No, it's not. It's not. It has the same importance as just like a normal thing because it doesn't have a double bond or triple bond. If it has a double bond or triple bond, then it would go up in priority. But because it doesn't, it's the same. Yeah, I know. It gets annoying. I think I covered. I think that's it for organic 1. Is it possible to have a ring on the end of the branch. Yeah. Yes. It's possible. With organic, there are endless possibilities. If it's at the end, I mean, you can think of it like this, right? Like this is kind of at the end as well, right? If you have something like this, I mean, this is a methyl at the end of the methyl, or on the other end, there's a ring. So this is technically what you said, right? If you have something that is super long, I guess, something like that, then yes, the cyclo would be the branch. It's the same importance, provided that the cyclo or the cyclic doesn't have a double bond or a triple bond. All right. Okay, so that's organic 1. Fun. If it does, yes, then it is more important. Yeah, if it does, then it is more important. Correct. Oh yeah, I'm starting too. Not wasting time. Okay. So functional groups are just special arrangement of atoms. We call them functional groups, right? So yeah, you'll be doing functional groups in organic 2, O02. So the first one is really quite simple, halogens. What happens if we have different halogens on our carbon, carbon chain? So there are 4 halogens that you need to know: fluorine, chlorine, iodine, bromine. They have the same importance as just normal carbon chains. They're not very important because they don't really do much. All right? So you still have to say where they are. So fluoro, chloro, iodo, bromo. So something like this. Let's do a triple bond, and let's add a whole bunch of fluorines in. And let's add let's add a methyl in too. Sure, why not? So you start counting from the right side because they have the same importance. They're not very important, right? They have the same importance as just a branch. So double bond or triple bond takes priority. So 1, 2, 3, 4, 5, 6. So the parent is hex 1-ine. Right? And then it's going to be 4, 4, 5, 5, tetrafluoral. F comes before M. 3-methyl. Hex 1-ine. Okay? So yeah, same idea as before. Alphabetical order, not very important. So double bonds, so multi-bond takes priority. Right? So this one's quite simple. The next one, alcohol. Alcohol is the functional group of OH. Right? So this is important. This is more important than your double bond or your triple bond. So you want to give it the lowest number. The way you show alcohol is with the suffix -nol. So you've done this before, right? Ethanol, right? Propanol. You can buy that at a Shoppers Drug Mart to disinfectant as a disinfectant. Yes, they're the same importance, which means they're not very important. So yeah, so let's give an example. Let's do a double bond here. Let's have an alcohol here. Let's have, I don't know, methyl group here. So here, even though the double bond is at 1, if you start counting from left to right, you have to start counting from right to left because it is more important. So you want to go 1, 2, 3, 4, 5, 6. So 3-methyl, hex, 5-ene, nol. Right? And your textbook will say, I don't really care. Right? It's just like, oh, it's English. Gotta take this E out, but who cares? But yeah. Oh, whoops. Crap. I forgot the 2. There we go. So this works as well. We don't count from, because the alcohol is more important. Yeah, alcohol is more important. Okay? And if you have multiple, well, same idea as before. So let's say this is what happens. There's an OH here. Let's say there's another OH here. Same thing as before, pretty much. 3, 4, 5, 6. This is a hex. 5, 2, 3, diol. Okay, so that's what alcohol looks like. Okay, so the next one is what we call an aldehyde. Aldehyde is a double bonded oxygen attached to a carbon. All right, double bonded oxygen attached to a carbon. And it is always at the end. The end, terminal. What I mean by at the end, it is terminal. Okay. No need to say where it is. No need for location. All right, and we use the suffix al. Okay, so make sure you write properly so I can tell if it's an OL or an AL ending. All right, so for example, and this is important, okay, so let's put an aldehyde group here. Let's put a double bond here and a triple bond here. Doesn't really matter. Let's put methane. Cool. So for something like this, 1, 2, 3, 4, 5, 6. So hex, 5-ene, 3-ine, ine, and then Al. You don't need to say 1 because it's important and it's always terminal. So you have to start here. You can also, I know this works as well, right? So there's the 2-methyl here, and that's it. Are aldehydes more important than the rest? That's where Bob comes in. So when you have multiple functional groups, that's where you're going to use Bob. That's where Victoria is at. So she's a bit ahead because she's now on to what is called multifunctional groups. So here you just have one functional group. Victoria is looking at compounds that look like this. So she, I don't know if Victoria can name it at the moment, but that's what she's looking at. Okay? So worry about that when it comes. We're just doing one functional group at a time. With the exception of, aldehydes, they're all more important than double bond or triple bonds. Okay? So that means you can also have something like this. You can have two aldehyde groups. Let's put a double bond here, right? So in this case, you have to start counting from here. 1, 2, 3, 4, 5. And it would be pent 2 in a dial. Okay. Good. Questions, concerns? Indeed, yes. For alcohols and aldehydes, no, alcohol doesn't have to be terminal. Look. The alcohol isn't terminal here. It's right in the middle of the carbon chain, right? Aldehydes have to be terminal. Has to be. Oh, you mean the suffix? It has to be the suffix, yes. For now. When you get to Bob, that's when it's going to change. So we're not there yet. But for now, it is the suffix. It is the ending. Alcohols are more important. Correct. Yes, they are. No. You will not get Bob. Not yet. That's too much for one quiz. It depends on priority. Correct. Well, you're okay. Yeah, you're there already, so you're ahead. All right. So organic 1 and organic 2 will be on the quiz. 0001 and 002. Okay. How would we do that kind of question on the quiz without Bob? Well, for this quiz, you don't need to worry about Bob yet. For the next quiz, I suppose, well, you've got more stuff to memorize. Surprise. I think you probably have guessed that already. But the Bob chart, you kind of have to memorize. So this is this unit has a lot of memorizing. That's it's part of it. It's part of the unit. Yeah. I have no idea. I'm still waiting for the memo to come out. I assume it's 2 weeks, but they're always changing. Like things are always changing. Like right now, we're still, I don't know, they're still talking about canceling March break or something. So I got no clue. I can't even plan for the rest of the semester at the moment because I'm still waiting for incompetent people that is higher up on the food chain to make stupid asses. Oh, sorry, pardon my French, to make stupid decisions because they suck at planning. Okay, so there's that. There's my rent for that. Okay, so we are good with aldehydes. Okay, so we're going to move to ketones. We'll end with ketones today. Okay, we'll end with ketones today. So ketones is pretty similar. It's double bonded oxygen. However, not terminal. So it is not at the ends, meaning you have to say location. Right? You have to say location. Somewhere in the middle, and again, it is important, more important than double bonds or triple bonds. Right? And we use own to show the functional group, to say that it's there. So for example, right, people that, not even people that took biology, but like testosterone, right? Hormones, right? Guess what? Hormones have ketones in them, O-N-E. It's implied. Well, it's in the name, right? So let's do an example. So this is what a ketone looks like. And here we've got multiple ketones in a double bond. So where do you start counting? Well, it's more important. So you want to give the ketones the lowest number possible. That means you have to start counting from the right side to the left. So 1, 2, 3, 4, 5, and 6. So this would be hex 5-ene, and then 2, 3, 4. Oh, ran out of space. Trione. Okay. That means I can also have a cyclo compound, and this can only be a ketone because there's no end, there's no terminus. So when I have something like this is still a ketone, and this would be 1, 2, right? So this would be a cyclo pent 1, 2 dione. There we go. So that's what it is. What underscore? What are we talking about? How would you name this? I don't even know what that looks like. Steven, what do you mean underscore? There's no underscore. It could be just my crappy writing.
I think he's talking about the thing I drew. So, yeah, so the question that I had was that, for example, you have a cyclo thing with just a triangle. And
Okay.
and
So
then you have,
cyclopropane.
right. And then you just continue the entire thing from both sides. So instead of connecting it to the main branch through a single connection, have 2 connections. Right.
Yes.
Exactly. On both sides. Yeah. How would you name that?
So it's just like the other one, right? It's kind of like this one where Terry was asking. Which one is it? Shoot. Okay, whatever. So you have a branch on a branch.
Right.
So let's say, I don't know, let's say this one's longer, right? So this one would be the parent, and then you're going to have a branch on a branch because the cyclo would be a branch, and then you got this thing on the cyclo that's part of the branch on a branch. Yeah.
Oh,
But don't
so
worry
you
about
wouldn't
those.
you wouldn't consider both the branches as one continuing thing and then the cyclo propane just on the main thing.
It would be easier, but that's not the correct way of naming it. It would be easier, but it's not the correct way. It's not the IUPAC way.
Okay, so and it wouldn't make a difference if both the branches are the same length?
If using the IUPAC method, one of them has to be the parent. So no, it wouldn't. You would just pick one of them to be the parent.
Okay.
They're the same length. Yeah.
Okay, thank you.
Okay. So okay. So is the functional group part of the parent always it's always the suffix. It's always the ending. Yes. Naming wise, it's always the ending. because functional groups are important. So we always give it the ending to show that it is the parent, it is important. When you get to Bob, so if you have time tonight, you want to take a look at Bob, you will see what happens if we have multifunctional groups. Some groups are more important than the other. So they have priority. What happens to the rest of them? You have to change them to a branch. And that's what Bob is. So yeah, I'm gonna stop here. We did a bit today. All right. So the lectures are online, so you can take a look at them. I didn't cover all like I just showed you naming and drawing for the functional groups. Okay, there's stuff like a primary alcohol, a secondary alcohol, a tertiary alcohol that I talk about. All right, so take a look at them. We can go over them tomorrow, but I just want to get naming and drawing out of the way because that's the part that I'm testing you on for the quiz, right? But yeah, okay, but yeah, I'm done. So yeah, that's pretty much it for today. So yeah, if you don't have questions, you can probably go.